Good afternoon, everyone. I don't know where Dan is, so I hope he will join soon. So in the meantime, I suggest we do some question and answer session. So uh, if you're working on some of the homework assignments, so if you have some questions, if you have some questions towards any previous lectures.
I would like to ask about this sick type challenge since I saw that there was already training data and development data.
Okay. Yeah. To be fair, I haven't looked at it in the recent time. So maybe if you looked at it, you can tell us what's the news there.
It's just the training and the development data were released.
Yeah, so it's free for download, I can see. It's quite big. Okay, so it seems that the training data is most of WALS actually. So there is 1,000 languages for training. And there is a development set, which is 84 languages. And it's pretty detailed actually, so it seems okay. So I can share my screen somehow. Makes more sense. Okay, I don't have to broadcast video. Okay, so on the ShareTalk website, I can see that yeah, it's true. There is the train dev data. So I've downloaded the train. I will also download the test, and we can look a bit on what's happening. Can make this a bit bigger. Okay, so it seems there are like 1,000 training languages and 84 development languages. And if I remember the format correctly, so you have to replace the question marks with something, or maybe I don't remember it correctly. So if there is something, so the dev data is also alt filled in. So does this mean that only the sample data is so there is the trial data as well, which should be so these ones are with the question marks. So I thought the dev data will be already for predicting, but that's not true. So that probably means that also the dev data is in the same format as train data, so all values are filled in. And this probably just means that if we want to try out if the method works, so we still have to use this trial data, because the question is like how many features you should expect to be filled in. So in the trial data, it's often like only one feature is filled in for the language, like here. And then, so the only thing you know is the order of adjective and noun, for example, and you should predict order of SVO, order of SV, order of OV. So, well, it's still possible, but it would be nicer to have more information for some more analysis. So, yeah, these. So the values are separated by pipes. So we need. So I would like to see. Okay, that's not it. So I want to take all pipes from the file and see how many there are. No, this doesn't work as well. Why doesn't it work? Okay. Okay, so this means there are some 40,000 features filled in for these 1,000 languages, so about 40 features per language. So this is quite good. This is quite large data actually. And if I did it correctly, there are no missing values in the train or in the depth. No. And so if we, for example, expect to find something for the, don't know how to pronounce, Niger Congo probably. So I wonder if there are any languages from this family. Yes, there are. So this means it should be possible. And so if I get the trial test data, so there are some languages. So let's say we would like to predict something for the Voodoo language, and actually it should be the order of subject, object, and verb. And we do have some other information. So it's, so we can, how was it? So we could try to look for the Niger Congo family, and let's try to look for the, come on, order of subject, object, and verb. Let's see what happens. And I want just a few values. So if I'm doing it correctly, then this feature is not filled in for any of these languages. Am I right? Okay. No, I'm doing something incorrectly. Order of subject, object, and verb equals 2. That's there. So it's written differently. That's fun. So in the sample data, it's lowercase, these features, while in the test data, it's capitalized. That's fun. Okay. So we could do a frequency list, right? So for example, we can see that in the test data, we are missing the order of subject, object, and verb for the Voodoo language, for Niger Congo. And so for the whole family of Niger Congo, we can see that the vastly most frequent order of subject, object, and verb is 2, which actually I don't know what 2 is. So let's just take one to see what this value means actually. Order of subject, object, subject and verb, object, order of subject to SVO. So subject, verb, object. Okay, so we can see that for the whole Niger-Congo family, the most frequent order is subject, verb, object. So that means we could guess for the value 2 for this language. Now, so this would be at least if well, I plan to take part in the task anyway. So I think the first thing to try out would be to just try to do this kind of majority voting based on language family. So so if you're interested in doing the task, I know about Martin that he is. So I would suggest the first thing to try would be just to make this simple approach running. And of course, we need to evaluate it somehow. And I thought there would be the dev data would support it, which it doesn't really do so well. So probably the way to go would be in the dev data. Let's try to predict these values for all the languages there. So so you would kind of pre-process the dev data. I think they published some evaluation scripts as well for that. So we wouldn't maybe even have to do it ourselves.
What's the difference between the dev data and the test data here?
Yeah, I'm also confused. I thought that there would be some values missing in the dev data to predict, but they're all filled in. So I suggest that what they mean is in the dev data, you should try to predict any of the values, even though it's filled in, as if it were missing. Where is my? So so there, all the values are filled in. So my approach would be, let's always take one as if it was missing. Let's suppose all the other values are there, so we can use all the other values except for the one which we just have chosen to predict. And let's try to predict it, because I don't see any better how to say any way, but I would also like to see, because they published some scripts. Okay, create train dev. That's probably just their internal script. I don't know. Select languages, more future. Okay, short coordinates. Okay, so yeah, this seems like the script they used to generate the dev data. It doesn't seem to do anything useful for us, I think. So we can see how they selected the dev data. So in this case, it's kind of useful. So they look for languages that have a reasonable number of features, and they try to look for some hard languages. So languages that do not for some reason that their genus is not one of those. I don't know if this is the train data or the test data actually. And definitely they look for some distances. So this is what they said they will try, that they will try to look for languages that belong to different genera and are distant. But in the end, okay, so yeah, so it seems that they want to make a non-overlapping set of genera of the languages. So for the train data, it seems they look for languages in any genus than these. I don't know how many, because I don't actually see the whole code. It's cut off. So that, and for the dev data, it seems that the opposite. They look for genera, for languages that belong to these few genera. So this probably means that there will be no overlap in the language families in the train data and the test data. This is what I take from it. So this already means that the first thing I said we could try, so it means we cannot probably. So let's check. The language family is what? 1, 2, 3, 4, 5. Okay, there is the genus is the 5th, family is the 6th. So there should be some matching families, but probably no matching genera. Let's look at the genera in the dev data. Okay. So there is a list of genera, and for the train, there will be a different list, and I cannot think of a quick way to compare that. But based on the code that we saw, I expect that they want to avoid any overlap in that. But in the language families, I think there should be some overlap. So they didn't exclude overlapping language families, just the genera. So for example, yeah, we have 6 Niger-Congo deaf languages, and the deaf is a simulation for the test. So in the test, in the task, we could expect again, like some Niger-Congo languages. And in the train data, we do have a lot of Niger-Congo languages. So we just know that they will be from a different genus, but at least from the same language family. So we could hope for some of the features to be shared across the whole family, or for most of the languages in the family, I think. Okay, I want to check my email if Dan is writing something. No, I just don't know anything about Dan. Interesting. Okay, so this seems, yeah, the first simplest approach would be just to look at the language family and try to guess that the missing features, and we don't have the missing features, so let's try to omit some of the features, and let's guess that they could be shared across the whole family, and let's see if this works. So actually for the Niger-Congo family, we have done this already, right? I tried to look for the okay, what was it? The order of subject, object, and verb. Okay, so I want to grab now for these, and based on the train data, my guess was that the order of subject, object, and verb will be the value 2, and sorry, I omitted -O, and so we can see that, yeah, I would be right. So for the languages in the dev data which are from the Niger-Congo family, so if we decide to predict the order of subject, object, and verb, it would be correct to predict the value 2 for well, both of the cases where this is filled in. And I don't know if in the test, I think the test data actually has a different format, but yeah. So, interestingly, in the test data, the genus is not filled in, just the language family. So it seems that there is some confusion on the part of the organizers as well, but should contain the genus in the end. So the sample data probably is different than what we will have. And okay, here on the website, it says that we should have access to the latitude and longitude as well, which I think is not present in the data, right? current. Oh yeah, it is there. Okay, so latitude and longitude is there, and yeah. So in this case, I'm not really sure what the purpose of the trial data is, because the trial data actually has a different format. It's missing some of the values. So it seems that there is still a bit of confusion. But anyway, what I expect for the real test data is that it will look something like the dev data, but just for some of the features, there will be a question mark instead of the value, as in the sample data they provided. So it would make sense to try to prepare such data to, and there is no script for that from the organizers yet, but we should probably ask if this is somehow deterministic, like which of the features will be missing and which of the features will be filled in. But we could always just say, okay, let's say the first half of the features is missing and the second half is there, and we should predict the first half based on the second half and based on the language family and genus. And then one thing would be, yeah, just let's use the family. The other thing would be, so this would be a voting approach. The other approach would be, let's try to find the most similar language in the training data. So this would be basically what was what was part of the first homework assignment that we did. So if we want to predict some features for the E. coli language, so we would look, okay, for languages probably from the same family, or maybe not. We could look for the matching features, and you would probably count some proportion of matching and non-matching features. And you could also measure the geographical distance. I think only one of you actually did that in the homework assignment, because it's yeah, it's not completely straightforward, but there is a formula that you can use, which you feed with the latitude and longitudes of the two languages, and or any 2 points, and gives you an estimate of how many kilometers there are between the 2 points. And so this way you can either find one language which is the closest, and let's just try to copy all the values from that language. And if they are not filled in for the first closest language as well, so then let's look for the second closest language and try to copy it from there. And let's continue until you fill in all the missing values. So this seems to be a doable approach. And so this would be like the second simple approach to do. And then you can combine the voting and the closest languages. So you would just say, let's take, I don't know, 10 closest languages, and let's have them vote on what values you would expect. And probably this could be weighted voting. So you would, so the closer languages will have a stronger vote, but so if you have a distance measure which you estimate for the languages, which is between 0 and 1, so each vote will have a weight of some number between 0 and 1. You can multiply this, and you could have a voting. So these are all the, I would say, the simpler approaches, which are more or less based on what you already did for the first assignment. And then it would be interesting, of course, to measure the accuracy. So to try to kind of randomly or deterministically remove some of the values in the dev data, and then compare the predictions with the real values to see how well this works. And I think the organizers also mention some related works and some expected accuracies, but I don't see it now. No. Yeah. So yeah, there are some citations of some works that already did something, so it would make sense at least to try to see how these work and to compare to them. Yeah, that would be the simple approaches, in the sense that they wouldn't take into account that there might be some dependencies between different fields. So it's easy to see for the word orders of different different members of the sentences. So usually there is some correlation between the values. So sometimes it's really deterministic. So if the order of subject, object, and verb is SVO, then order of subject and verb must be SV. There is no other option. So there are these easy cases, but there are cases where it's rather some correlation. So for example, order of adposition and noun phrase, so whether the language uses prepositions or postpositions, is somehow correlated with the order of the other things. And actually, I don't remember what the correlation is, but well, that would be to see from the data. So this would already be something more interesting. So trying to find some, let's say well, it's correlations. So some correlations, we could extract some rules or some soft rules from that and see, okay, so yeah, for this, yeah, I think it would make sense to use some statistical tests for that. So try to find some high enough correlations, or try to do some statistical significance tests to see if this kind of correlation is actually significant. And if so, then let's try to extract some rules for that to fill in the missing values. Like if the language uses postpositions, then the order should be this or that. And again, you would have then either some direct rules or again some voting, so it would give you some estimates on how likely it is that this value will be this or that. So this is basically what I suggest to look at. And as I said, so if this sounds interesting to you, well, to any of you, then we are willing to let you work on this task instead of doing some of the homework assignments. And this is kind of up to you. If you say, okay, this homework assignment seems boring, so I don't want to do it, I would rather work on this this SIG type task. So so I think all of you here actually did submit something for the first homework assignment. So this means you're definitely free to skip any of these assignments and try to extend your first homework assignment to a solution to the task. So, and I mean like at least some simple case, so some either the voting based on the language family or the finding the closest language. That's probably based on what you already have for the first homework assignment. So try to use what you have and try to do this task. So so I don't know. So how many of you would be interested in trying that?
I would like to do it, this task.
Great. So yeah.
I don't know. I'm still not sure. I'm still considering it because I don't know if I have time for it.
If you have time for what?
If I have time for it.
Yeah. Well, you either have to do the homework assignments or this thing anyway. So it's just swapping some time for the same time just spent doing a different thing. And of course, like if you spend a lot of time on solving this shared task, then you can skip multiple homework assignments. That's just, it's basically the question is which you find more interesting or more fun. And I mean, all of the homework assignments are published on the website, and they will probably change a bit, but not significantly. So you can already get a good vision of what to do. So
I still don't get what the point of this whole shared task is. Like, why would we not get linguists to fill these gaps? Why do it via some like statistical properties that we're trying? This is what I don't understand.
Yeah. So, well, the simplest answer is because there is just too many gaps. I forgot how big the walls is. I don't know if I have it downloaded somewhere here, but it definitely has some, what, thousand of languages or something. And well, we have the train data here is 1000 languages. So that's definitely taken from WALS. So it means WALS is a bit bigger. And for 1000 languages, and you have like 100 features, and most of it are gaps. So this would mean you have to fill in 100,000 missing values. That's a lot of work, and a lot of the languages are very exotic, let's say, which means we might have real trouble getting some linguists to meaningfully filling the values. So if it's a language, I don't know, spoken by some 100 people somewhere in some jungles or some other remote areas, then if you don't have like some good data or something, so then you would technically have to send some person there to ask the locals, like, okay, tell me some sentences, and I have to fill in some features. So that's basically where most of these values come from. So it's field studies. So it means some linguists went to some funny areas and they recorded the people speaking. They asked them for some things about the language. They tried to learn the language, and they came up with some information about the language, some recordings, and that's often all we have. So you have to interpret the data you have, and you just have to trust the data, and often it's just small data. Or for a lot of the languages, okay, you have, I don't know, translation of a part of the Bible, so you might try to look into that, but if you don't understand the language, then still it's hard. So the linguists, they can surely fill in the big languages. So I don't know, the big European languages, that's easy to fill in. The big Asian languages, again, that's easy to fill in. There are thousands or millions of people speaking the language, so there it is easy. But this is just a small part of WALS, as we were talking about. So I think like that, I don't know, you can fill in 10% of WALS, maybe, are the big languages, and the rest are really small languages for which not much is known. For the big languages, you don't actually need WALS so much, because it depends on what you want to do. But what we are interested in this course is that we want to somehow work with languages for which there is few data. And this is already what was the point of the first assignments that we had, that you want to so you want to work with a language for which you don't have sufficient data, and you want to find some close languages to it. And if you don't have sufficient data for the language, so there is a high chance that it's actually one of the small languages. So it's hard to learn a significant amount of information about the language unless you have that information in WALS, because it would be hard to find speakers of the language, or to find some significant amount of materials about the language. So there are basically two approaches, or three. Okay, so one approach is, let's ask some linguists, let's ask some speakers of the language, let's get the information about the language, then we can work with it. Or you use WALS, which is kind of a proxy for that. And if it's missing in WALS, or if the values are missing, then it would be super useful to be able to just automatically predict the values in WALS, so that we don't have to ask the people. We just say, okay, it's probably this way, and some of it will be incorrect, but if the accuracy is 90%, that's still super good. And then the last thing that people do is, let's just use some texts in the language and let's just find the features ourselves. So this is something we're not going to work really much in the course, but it's the other option. So let's just get the text of the Bible, and we can probably figure out what's the word order in the language using the text of the Bible. So these are kind of the three ways you can go. And so using WALS is a useful way, and it's so it means that if WALS didn't have so many gaps, And especially it has a lot of gaps for the small languages. So then if it didn't have these gaps, it would be useful, but it's super hard to fill them in manually because there are just so many and the languages are weird. But we guess that using statistics, basically using some correlations, we should be able to fill in these values. So, so that's kind of the point of the task, I would say. I don't know if I answered the question.
You did actually, but I still find like that all this effort that's being put into generating automatically these values could be invested in like going to actual linguists to, I don't know.
Yeah, well, you might be right. That's fair to say. It might be true because this is something that we will probably mention maybe even today on the course, that if you try to do these automatic methods to automatically predict something for a language without having the real data or the real information, so often the results are that, okay, we managed to get something with a lot of effort, but if we just ask somebody who knows the language or ask some linguists who can tell us something about the language or who can annotate, I don't know, 100 sentences in the language, then we could get the same or better accuracy. So that's always a question, and the answer is not always clear. For some languages, they're just weird. But so if you want to focus on one language or 10 languages and solve them, then yeah, surely you should just go ask linguists or speakers of the language. If you want to do something for 100 languages, 1,000 languages, then already it makes sense to try to predict something automatically because there are just too many languages to do that manually. So there is a threshold, definitely. So if you're, like in your case, you might be interested in Lebanese Arabic, so then it makes a lot of sense just try to get some data manually, of course, because it's just one language. And if you're a speaker of the language, then it's definitely easier to just add some data manually or add some features than to try to predict them. So in this case, it's just interesting to see, okay, so how well can we predict the missing values, compare our prediction with our real knowledge, and then we can extrapolate, okay, but if you want to work with all varieties of Arabic, which I don't know if there is an official number, so let's say there are 20, so then already you would have to ask speakers of all these 20 languages and explain what you need, and then already you might want to use some automatic methods to predict some things that are easy to predict. So there is, that's about a threshold there.
Yeah.
So yeah, but yeah, I'm admitting that it's not always if you're interested in getting the best results for one language, then it's not always meaningful to try to do this automatic methods. But it's of course more interesting research-wise. Like if we can do it really well, then it scales to thousands of languages, and that's cool. If you just annotate it manually, then well, you have to do it manually for all the languages. So it's like
you're
this.
right, but like I'm going from the rationale of like languages are kind of a closed class, so it's not like we're creating languages every day. So since we're dealing with a closed class of items, like I don't know, I would go for the manual annotation.
Yeah, well, it's a good thing that you mentioned this, because it's yes and no. So yes, new languages don't really emerge often, but no, in the sense that you have different domains of the languages which work similarly. So I don't know, you have data maybe for newspaper text, but then you realize that if you want to analyze, I don't know, some laws, or you want to analyze texts on Twitter, or you want to analyze movie subtitles, then that's a different language already. But not really, it's the same language, but it's so different then that some properties are different, and you have to adapt the method somehow. And it's a similar problem. It's not the same problem. The methods would be similar, not the same, but it's worth thinking about this thing there as well. Okay, I can see Dan has joined already.
Hi, everybody. I'm really sorry. I just messed up various days, so I thought it was I was supposed to be here in 1540 today.
Okay, so Dan, just what we did. So yeah, we actually we looked at the SIGTIP shared task. So we were so they released the train data and this data. So we looked at it and we planned what we could try to do with it. And Martin is interested in doing that, and Chris maybe as well. So he's kind of doubting whether it makes sense, but yeah. So that's what we did. So we haven't looked at the post tagging yet at all.
Okay, so should we switch to that now, and
I guess
should
so. Yeah.
take my slides?
May I have a question?
Yes.
Sure.
Last week you mentioned that we are recording this and it will be somewhere.
Yes.
Somewhere. Where will it be?
The last week's video is already available since last Friday. There is a link from the website of the course.
I can try to show it if
So it's actually the link that that was there saying online class now goes to the recording, while today's goes to the Zoom meeting.
Okay, okay. So, I didn't try that.
Yeah. So if you click it, so you get to the video.
Okay, great. Thank you.
Okay, so I'm going to launch my slides. Here we go. Great. So the next topic that we have is actually starting the first item in a sequence of related topics where the main or the common theme is that we have a language for which we have little or no resources, and we want to be able to use existing tools that we have for other languages without really sitting down for a couple of years and annotating data for the new language. And there are various techniques that people have been trying to use with various level of success. And in most cases, is essentially the main idea is trying to port knowledge, transfer knowledge from one language to another language. If possible, then the two languages should be linguistically related, because obviously then it is more likely that it will be possible to transfer the knowledge more successfully. So we are now going to start with part of speech tagging, and later on, I don't mean today, but next week perhaps, there will be something about parsing as well. So that's why it's called cross-lingual part of speech tagging. And the main idea is, at least in this this particular set of techniques that I'm going to cover today, is that you need some sort of parallel data. So translation from one language to another, where one of the languages is the resource-rich language for which you have some tools, resources, corpora, whatever, and for the other language, that's the target language, you don't assume having much more than the parallel corpus. And the idea is that it's often easier to get a parallel corpus than the other resources like dictionaries with morphology and maybe syntactic annotation and so on. It's not necessarily always the case. There are many languages for which you don't have anything, not even parallel corpus, or the parallel corpus is just the Bible and nothing else. But still, this is definitely there's a possibility that that this will help with a lot of possible target languages. So this is also the sort of classics in any transfer techniques across languages. That's the part of speech task in this context has been first tried in 2001 by David Jarowski and Grace Nye in Baltimore. So I will, as I always do, I will have citations of the papers which my talk is based on. So that's also, you can take it as pointers for possible further reading about the more details. So this was called inducing multilingual part-of-speech taggers and NP bracketers. That's I'm not going to talk about that part, via robust projection across aligned corpora. And they tried it on English and French. So English was the source language and French was the target language. And the second pair was English to Chinese, where obviously Chinese is much less related to English than French is. So that sort of was meant to underline or verify that it is still somewhat useful if the two languages are not so much similar to each other. And they had parallel corpora available. All the three languages are large languages for which actually there is a lot of resources, even part-of-speech taggers, but they needed something to be able to validate the approach. So they tried it on these languages, while the idea is that if it works, then you could actually apply it to a language for which you really don't have any resources available. And as you may know, at least if you attended some of the machine translation courses that we have, it is not so difficult to, if you have a parallel corpus, to automatically align words on one side to the words on the other side, to know which word is supposed to be translation of which other word on the other side. This is an unsupervised approach, so there will be some noise, there will be some errors, but if your data is large enough, then you have a good chance that on majority you will have real alignment between the words that are translations of each other. So they used here the IBM Model 3 with the Egypt tool, which was, I think, the most popular and state-of-the-art thing at the time when they were doing it. One warning here is the assumption of that tool is that you can have 1 to n alignments between one English word and one or multiple target words, but not the other way around, which obviously is a simplification. You will find situations where you would want to align one target word to multiple English words, but if that happens, then the only option that you have is to select one of them as the representative of the English multi-word sequence and leave the others as unaligned words. So you can have unaligned words on both sides. And once you have it, then because we also assume that we have enough resources for the English side, so we should have a tagger, part-of-speech tagger for English. So they used the Braille tagger, which was one of the good taggers at those times. Now we would use some sort of neural tagger probably, but that's the real, the nature of the tool that you use on the source side is not the most important thing. You can just use whatever you have. And then they tag the English side with the tagger, which will give you not just a tagged English corpus, but a tagged English corpus particularly for these words that are aligned to the target language. And then you can project the tags across the alignments. While sometimes, obviously, there will be issues with this. So for instance, here we have, on English sides, we have laws without the article. And on the French side, we have les lois with the article, the definite article les. And if the English side says laws is a plural common noun, then there's no information that would tell us that the first French word is a determiner. So instead, we only know that it is something corresponding to a noun. But we see that there are two words corresponding to the noun, so we can say this is NNSA and NNSB, which will still distinguish somehow if whenever we have a two-word phrase corresponding to an English noun, we still know which one is the first one, and that might help us. Then it may turn out that if we look at many such pairs, that the first word tends to be actually something like a determiner, even if we don't know that we want to call it a determiner. Now, because obviously they knew that there would be a lot of noise caused first by the alignments not being perfect, and second by the tagger not being perfect, because this is not hand annotated part of speech text on the English side. It was assigned by the tagger, so the tagger could make errors of its own. So there's a lot of noise, so they decided to only focus, at least initially only focus on what they call core tags. And this means they in general they work with the Pentry Bank tag set of English. And if you know it, then you know that whenever there is multiple part of speech categories that you would cluster together as one coarse part of speech, like nouns can be common nouns and proper nouns, and they can be singular or plural, then all of these tags will start with N. So they essentially take the first letter of the tag and say whenever it starts with N, it's a noun. And J is adjective, and verb is V is verb, R is adverb, and I is preposition or subordinating conjunction, probably because the real tag is in. And then there is a number of tags that are completely ignored, various auxiliary words and determiners and so on. So they wanted to real focus on stuff that is likely to be attested cross-linguistically and hopefully mapped to the same category in the target language. Then the second thing that they did is what they call aggressive smoothing towards the two most frequent core tags of each word. So this means they look at each word type now without the context. So essentially, if you see a string, a word from the lexicon, you decide that there are at most two possible part of speech tags that you are willing to assign to this particular word. And if you have observed more than two tags in the corpus, then you will ignore the less frequent ones. So that's what these formulas do. You select a way lambda 1, which you multiply with it the probability of the second most frequent tag. So this T sub parenthesis 2 means the second most frequent tag for the word W, and T1 is the first most frequent tag, and TC is for C greater than 2. That those are the other possible tags that you have observed. So those will have a normalized or smooth probability of 0, and the probability mass will be distributed just between the first two. And this is just for the coarse grained tags. Now they didn't want to completely discard the more fine-grained part of speech classes, but they first wanted to focus on the main category. And once they specify that it's either, let's say it could be a noun or a verb. So it's either a noun or a verb and nothing else, even if there were some occurrences of some other possibilities. Then the second step will be for the nouns to decide whether which one of the noun categories should apply here. So they will still try to predict one of them, but again, they will recursively apply the same smoothing approach. So as I said, there is common nouns and proper nouns, and each of them has a singular and plural tag, while here we again see only two of them. And these are the common noun tags. So proper nouns will be ignored. They will have to be subsumed under the common noun tags because they were not frequent enough. If this is an example. So if this is really what happened there with the probabilities. And then they also do another interpolation or another simplification of the model. They take these probabilities from the model that was obtained from one-to-one alignments. So really one English word corresponds to one target word, which is something that intuitively might seem more trustworthy in situations. So, but it's not for sure. So you can still train the weights, whatever will come out as the more important model. And then the other model obviously is the rest. So the model obtained from the 1 to n alignments, where n is greater than 1. And again, you can interpolate the probabilities of the word that you obtain from the two models. And by setting the weight lambda 2, you will decide which of them has what proportion of the credibility. So these are parameters that you can set for the when you play with it. And then finally, they also, because when you create a tagger for the target language, the tagger essentially is a model of tag sequences. So it's not just the probabilities of a tag given the word, but it's also a probability of the tag sequence. So how likely it is if there were two nouns in the two preceding words that the next word will be a verb, for instance. And this model of the sequence is something that they estimate separately, the model of this, and they do this on the projected tags. So now we are in the target language, let's say French, and for each word we have a projected tag, and we now want to train a French tagger on the French data, which is very noisy. So what they do is they will select alignments that they trust more than the others. First, the aligning tool is able to tell you how confident it feels about each alignment. There is some confidence score provided by the Model 3. So you can know from that score whether in a particular sentence the alignments are to be trusted more or less. So you can set a threshold and only use sentences where you believe the alignment was better. And then the second thing that you can do is that you can compare the actual text in this sentence with the tags, the lexical prior tags, they call it. So the ones that we talked about on the previous slide here, with the actual sentence. Because if we cut the probability distribution so that, let's say, if there were 3 possible tags for the word dog, and let's say it was a noun, and I don't know what would be the next possibility. Adjective and verb both sound a bit weird. Let's say verb was the second one, and the third one was adjective. So we discarded the possibility that it was adjective. And now if we see a sentence where the dog appears with the tag adjective, then this sentence is less compatible with the lexical model that we created in the first step. So such a sentence will be less useful for modeling the sequences of tags, because we don't believe too much that our tags here are correct. So that's the other possibility where we will just cut the data and only take part of the data where we believe more in what we see there. So that's roughly what they say about their experiments. Obviously, you would need to go to the paper if you really wanted to re-implement it. But I hope it's now at least approximately clear what they were doing. If not, then raise your hand. We can discuss it. But that's the first approach to this, and obviously there were many other people who followed up and tried to do more in that respect. So with the general setting that you have a part of speech tagger for source language, and then you have the parallel corpus aligned word by word. So one of the noteworthy follow-ups was the work by Dipanjan Das and Slav Petrov in 2011, which I will briefly cover in the next couple of slides. And then also I want to mention Željko Agic and others from Denmark in 2015, who, as far as I know, they didn't change the technique too much, but they actually applied it to a massively parallel corpus, in this case the Bible, where they really computed the elements across all the available pairs of Bible translations. So even though Bible is such a specific domain, they were able to cover this way many languages that otherwise don't have anything for part of speech tagging, or didn't have until this work. So now let's look back at the Das and Petrov work. What they introduced new was they call it projection graph, and we will see an example in a few seconds. So there are, as a graph, it has vertices and edges. There are English vertices and the foreign language vertices. They will be Italian in the examples, in the example that I will show you. And again, the vertices correspond to word types. So again, it's without looking at the sentence context in the corpus, but in the case of the foreign words, there is already some sort of context, because here the vertices correspond not just to word types, but to word trigram types. So trigram means that those were three words or tokens that appeared in a sequence in the data somewhere. And they are connected. The English vertices are connected to foreign vertices wherever there was alignment in the parallel corpus. So those sort of correspond to the hypothesis that this is translation. And then the foreign vertices are interconnected to other foreign vertices, which signifies the hypothesis that they are similar in some sense. And if they are similar, then that gives us some confidence that maybe the part of speech tag should be also the same for both. So in this example, we have like 1, 2, 3 English vertices: enactment, imprisonment, and character. In this case, all of them are nouns. Although if we saw a larger subset of the graph, then we would see other part of speeches as well, and then there could be some mixed results. So here it is easy, everything is a noun, and some of them are attached to their Italian counterparts, and then there are and the Italian counterparts are the middle words of the trigrams. So the trigram always gives you a larger context, one word to the left and one word to the right. And then there are edges between the Italian trigrams, which show the similarity between trigrams. So you can see here that we have two nouns. The nouns are different, but the context is the same. There is suo, his, I think, or her, on one side, and the comma on the other side, and we have the same thing here and the same thing there, and here we have il instead of suo, but still there's a comma, and so on. So obviously there is some sort of similarity, and what is not visible here is that there are weights associated with the edges. So the weight will tell you how much similar it is considered. So to repeat, what we need for this is the parallel English foreign corpus, word aligned, and as we know, the word alignment can be achieved automatically. And the English side is labeled by a supervised English tagger, so we know what part of each category the English words are. And then we need a monolingual foreign corpus. So assuming this is probably a larger corpus, but you don't need the parallel alignment to English, so it is much easier to obtain typically. And you don't need any labeling on that corpus either. So the only thing is that you will see the trigrams. You will be able to observe that the word imprisonment or whatever it was on the previous slide typically occurs in this and this and this context. And then you will see the same context somewhere else, and that will give you the hypothesis that they are similar in some sense. And then if we have such a graph, the last step to do is we can propagate tags across the edges. So again, here it was easy. If we saw a noun and noun, the only thing that you can propagate is a noun, but you can actually do a soft propagation where you will have a probability distribution, which will tell you, depending on the various edges that that come to the node, that charactere may be a noun for like 90% probability, and then 5% possibility it's an adjective, and so on. So this by combining all these sources of information, you will be able to tag the target corpus. Then they have they define multiple features that they use to train the similarity weights. So we don't, I think, need to go into much details. Essentially, there is a trigram type. So these are 3 words that occurred in the trigram. And then they actually observe a larger context, which was not visible in the graph. So they take 5 words, 5 gram, where they take the features from. So you could also look at the context, like X1 is not part of the trigram, and X2 is part of the trigram, and that's a feature called left context, for instance, and so on. And they use these features, they train it on the large monolingual corpus, and the features will tell them which what the level of similarity between the 2 trigrams is. So that was, in a nutshell, the approach by Das and Petrov. And I have one final paper to report on, which also is related to this topic, but it's even a newer one, and it also uses a parallel corpus, but it works slightly in a different way, or you could say in a reversed way, and we will see how. It was defined for, or the experiments were done on Indian languages. In India, there are hundreds of different languages, and at least dozens of languages that are large enough to really have the critical need to get some NLP tools available. And the languages in India essentially come from 2 major language families, plus at least 1 more family for some minority languages. So the 2 large families are the Indo-Aryan languages, which is a sub branch of Indo-European languages, and the other one is Dravidian languages. And they are not related at all, even though there are some lexical overlaps. But this paper actually claims that they tried their experiments on both the large families. So both the families contain languages that are morphologically rich. And as we will see, that was part of the motivation, that they tried to capture the morphological features that are hidden in the words of the languages. But the morphological devices are not the same. So there are similar devices in Telugu, Tamil, and Malayalam, because there's the Dravidian family. And then it's somewhat simpler and similar to each other among these languages, Urdu, Punjabi, Gujarati, and others. So we will see examples from Hindi and Punjabi.
When we say resource poor, do we mean a lack of corpora or lack of annotated corpora?
Essentially, we mean lack of annotated corpora and tools that you could train, like the part of speech tagger. Okay. Because corpora usually are, you know, for some languages, even corpora is a resource that is scarce. But these languages are really, all of them that are listed here, are large languages with tens of millions of people who speak it. So those people also are, at least some of them are active online. So there are tons of text that you could just get from the web, but it's not annotated.
Okay.
So for these languages, still the prerequisite here is that we have a parallel corpus, which we can word align. That is sometimes a bottleneck of these methods. They fortunately have it for these Indian languages, but unfortunately, this particular parallel corpus that they have is not publicly available. So you would have to be an Indian researcher to get it. So that's a problem for us. If we want to try it, we can try it on other languages, but for the Indian languages, we would first need to get the health and tourism corpora that they often cite, but the license does not allow them to publicly distribute it. Then they used Giza++, which is a newer version of that Egypt tool that was mentioned by the previous guys. And to align the language pair that they chose, so they work for each pair of languages separately. And essentially the usual source language for them is Hindi, because they have a rather large set of tools and a large corpus for Hindi. So it is easy to start with Hindi there. Yeah, here we go. So there's like, again, this is cited from the paper. So 450,000 tokens that may not be up to date if you just Google Hindi tree bank today. But that's what they used. And then for each word in the corpus, they look at a set of features. Again, they define their features, and you could define them somewhat similarly or differently, whatever you want to, but the general idea would be the same. So they look at individual characters and or sequences of characters. So they take prefix features. We will see an example on the next slide. Suffix features. They also look at the length of the word and previous word and current word. So these are already context features in the sentence. But up to here is just features of the single word without looking at its neighbors. So here is the example from the paper. Patrakaron means journalists in the plural form, and prefix 1 means the first character and prefix 2 means the second character. Just note that if you look at the Roman transliteration, it does not necessarily look like you are adding one character at a time, but that's because of the specific rules of the Indian writing system, or this particular Devanagari writing system, because they have this like implicit vowel a in the character for p, so it's like pa, and then if you add t, it's pata. But then if you want to say that there is not this implicit a at the end, then you have to add a specific diacritical mark, which is a new character. So now you have 3 characters, but the Roman transliteration looks shorter. So this is just for you a warning, so that you are not surprised to see that. Otherwise, it's pretty straightforward. And from the end, again, this one is just a diacritical mark, but it's a single Unicode character. So it's the thing that we will cut as suffix 1 and so on. Now, here is another example, but this time it is from a parallel word pair. So on the left-hand side, that's a Hindi word. Both of them mean the same, merit. So in Hindi, it's vivahit, and in Punjabi, it's vyahuta. And there's also a different script for Punjabi with similar properties, but it's different segment of the Unicode characters. And if you go one by one character, this is what you get. So sometimes there is clear correspondence. Sometimes there is, because there is a long vowel here without the second V. So you get something less parallel, but still quite parallel. And you go up to the length of 7, and then from the other end you take the suffixes, and so on. So it's so far it's rather straightforward. So here's how we can create a mapping between Hindi features and Punjabi features from the parallel corpus. So we will maintain a large table which will tell us that va can be translated to this Punjabi wa, and so on. Now there are several points in the article that unfortunately are not clear from the text of the article. So if we wanted to re-implement this, we would have to either reach to the authors and ask them, or to experiment with that. But even with these unclear points, I think this method is still quite interesting. So I wanted to present it, even though I don't have answers to everything. So one of the unclear points is that at one page they say only the 11 FX features are projected from the Hindi tree bank to the target language data. So I actually don't know why they define the other features, the context features, the next word and the previous word. What they do with it if they don't project it. So that's one thing that I cannot answer if you want to ask. But otherwise, they can project features from Hindi to Punjabi. Now, it can also happen that the same source feature, the Hindi feature, maps to multiple target features, because you will observe it at several words, for instance. So or the words will have different alignments. So sometimes you will have one mapping, sometimes you will have another mapping. What they say here is that the most probable target feature is selected. So it looks like the aggressive smoothing of Yarovsky and Guy, that they just drop the rest. They have 11 mapping files, one for each feature type, and if on the previous slide there was just one aligned pair of words, so now if it occurred multiple times, I would assume that whenever they want to map the feature to something else, they will note down how many times they wanted this target feature and that target feature, and later on they will just keep the most probable one. Another unclear point here is if they say the most probable one, you could also think of the probabilities of the alignment, which is something that you could have from the alignment tool, and they don't say whether they look at it or not. But that's also something that we want to think about. Now, it's also possible that there is a source feature because you look at the Hindi data, but there's no projection available because it's a tree bank. So you have parallel data. Parallel corpus is one corpus that you have, and the tree bank is the other corpus. So you see something in the tree bank, but you never saw the same thing in the parallel corpus. So you don't have a projection. So then they say that they have a backup model. So if the longer feature doesn't work, you look at the shorter feature. Again, if we wanted to implement it, we would have to answer some related specific questions, like do we map the long source feature to the short target feature and pretend it was the same feature, or we just omit the long feature and ignore it, or whatever. So that these are not exactly the same things. But now I think this is the more interesting part. What do we actually do with it if we can map the features? the Hindi tree bank has the part of speech tags for Hindi, and what we want is the part of speech tagger for the target language. So we essentially map for each Hindi word. We take the Hindi features, which we can easily see there, and we map them to the target language. So now we still have the Hindi tree bank, but for each word we have, let's say, Punjabi features. And so it's something like if we translated the Hindi tree bank into Punjabi in a very naive way, sort of word by word, but we even do it not just word by word, but rather morpheme by morpheme. And then we train a model that looks at the Punjabi features and predicts a part of speech tag. And if we have such a tagger based on those features, then we can apply it to Punjabi, because if you take a Punjabi text, you can easily get the Punjabi features for each word, and you can feed them into your model, and the model will tell you the part of speech tag, right? So that's the main idea here. Again, the machine learning part of that could be virtually anything. So the method they used in the paper was CRF++, the conditional random fields, but you could do the same thing with a neural network, and the idea behind it would be still the same. So that's what I had to say today. I think I'm now out of the time that we had. Once again, I'm sorry about coming late. So you had different practicals today. Now, if there are any questions, I will try to answer them. Anyone?
Okay then, since there are no questions, so I suggest that officially the class ends, so we cannot keep you here anymore. So this means as homework assignment, so either you can try to work on the SIGTIP task as we talked about in the beginning of the class. So in that case, yeah, I will try to put online like a few points on what we said. So basically, try to omit some values from the dev data and then try to predict them and measure how well you did. So this would be the task based on the SIGTIP. The other option, as usually, is to do the task written on the web page, which is obviously post tagging across languages, so projecting the tag. So I have updated the website a bit so that it contains information without errors. There were some errors previously, so if you were looking at it, so just you might have a wrong version. And I suggest that either we just finish the class, or if you're interested in doing the post tagging assignment, so I will now be just quickly demonstrating what it is and how to do it. So I think it will take me some 10-15 minutes. So either you can stay here and watch me demonstrate it, or you can disconnect, and in any case, it will be recorded so you can get back to it even afterwards. So either you can leave and do the SIGTIP assignment and ignore the post tagging, or you can stay and see how to do the post tagging assignment as well.
Okay, thank you.
Okay, so if there is nothing else, so I'll now switch to the post tagging assignment, right? So if there is something you want to say, so say it. I will share my screen again. Okay, so I hope you can see my screen now.
Yes.
Bigger. Okay. No, that's the previous one. Sorry. Posting. Okay. Obviously, I haven't updated the deadline. I'm sorry. I will. Fine. So the post-tagging assignment is basically to, as usual, try out what you heard about in the presentation, which would mean, which would mean to take a language and try to predict the part of speech for the language without training on data for that language. So in that case, an under-resourced language for us will mean a language for which we don't have part of speech tag data, or we do have them, but we will pretend not to have them and simulate the case where you really don't have the data, which is like, I don't know, 95% of the languages in the world, you don't have part of speech tag data. But we will assume that we do have parallel data, which we do have for 1,000 languages. We do have some parallel data, at least the Bible. And so basically, the task is to get some reasonable part of speech tagging accuracy. I suggest to use Kazakh or Telugu, which are both, let's say, low-resourced languages. So in universal dependencies, there are some data, but there is not many. So it's useful for test data. To train on it, you can train on it, but it's not huge data, actually. It's possible. It may be possible to get a better accuracy with not using the training data, but projecting from a similar language. And of course, part of the task is to choose which is the similar language to use for the projection. And obviously we've done that in the previous assignments as well. So now just try to find out what would be a good source language for Telugu or Kazakh. And as usual, you are free to choose any other languages, even high resource. Just it's important to try to do the task. Fine. So what we're trying to do is using some parallel data. And what I will be showing here is projecting from one language to another language, and I will show it on Czech and English. So I will assume that I have no tools for Czech, but I will have tools for English. So I want to project English part of speech tags to Czech, which obviously is a weird example, but it will make it easy for us because we will understand at least one or both of the languages being shown, so we will clearly see what's going on. Whereas in your homework assignment, you should take a target language, which is hard. So yeah. Then there is a bunch of parallel data you can use. There is some older version of the Watchtower corpus, which I've made available for you. And actually now there is a newer version which is published officially. This one is kind of unofficial. And you have here for I don't know, 100 languages, you have a list of sentences which are parallel. So for example, the English and Czech, I will show what I mean by that. So there are some English sentences, and then there are some Czech sentences. And if I paste the English and Czech sentences and view them, and I will show the line numbers. So typically there will be the same sentence in English and then in Czech. So this is what it means that it's parallel data, which is sentence aligned. So the line is the same line in both of the languages. In some cases, some of the sentences are missing. So I can't see anything quickly now. For example, here, okay. So for example, on line 15, there is just the English sentence and the Czech sentence is missing. So there are some gaps in the data. You're used to data with gaps. So that's no surprise, because we only have some of the sentences in both of the languages. And you're free to use any data that you find, but this is already kind of prepared in this usable format. And now, so the task will be to use the English sentence, and I will just take, for the example, I will just take the first English sentence. So the hope of being saved can help a person to hold on even in the direst of circumstances. So that's actually a nice sentence. It's the Jehovah Witnesses Watchtower magazine. So, well, it's a bit weird data, but whatever. And the first check sentence, naděje na záchranu nám může pomoci, abychom snášeli ty nejhorší okolnosti. So your task is to assume that you can get part of speech text for the English sentence using UTPipe, and then transfer these part of speech text to the Czech sentence. So I've already tagged the English sentence, but there is the command is not surprising. So you use UDPipe, you give it to model, and you get the output. So for English, it looks like that. You get a lot of information, but actually we probably just want to look at the words and their part of speech tags. So this will be the data that we want to use. And for Czech, we obviously want to put the data into a similar format. So in Czech, we assume that we just have the text tokenized, and we've covered how to tokenize text if you don't have a tokenizer for the language. And we don't have the part of speech text, so we want to project the part of speech text from English to Czech. That's one part of the information. The other one is we need to get some word alignment. So we need a tool to tell us which of the English words corresponds to which of the Czech words. And for this, I suggest to use FastAlign. It's a tool that you can easily install just by copy pasting these commands. And then you prepare the data, and it gives you word alignment for the data. I will make it a bit smaller because it cannot be seen. So there is just some pre-processing, and it expects to get one file where there is the sentence in one language, then 3 pipes, and then the sentence in the other language. And you have to get rid of the cases where one or the other sentence is missing. And you can do actually alignment in 2 directions. It's called forward and backward, and then do an intersection, which means that you get just the links that came from both of the languages. And I will just show what the output looks like. So if I run this command, so for the first sentence, I get English, Czech, English, Czech, F1, this was the file, oh yeah. Okay, so I will show again the Czech sentence, and you get a file which looks like that. So it tells you which words correspond to which words. And unfortunately, the format is different than UD. So it uses 0-based indexing, whereas UD uses 1-based indexing. So you would have to add 1 to the numbers here to get the real links. But let's see how this works. I have here the data pasted somehow. Okay, yeah. So these are.
How is it aligning the two? How is it aligning the 2 languages?
Yeah. So technically it aligns by running this code, and what happens inside is that it looks for words that appear in the same sentences, and it guesses that these words correspond to each other. So that, and I have this somehow. Yeah. So for example, so this is already with shifted numbers, and okay, some are easy, like the dot corresponds to the dot, but like number 18 in English, circumstances. So it aligns it to number 13 in Czech, okolnosti, which is correct. These words mean the same thing. And what it internally does, it goes through this parallel data that you give to it. So these are some, I don't know, 100,000 sentences. And it computes how often these words co-occur in the same sentence. And it figures out that English sentences that contain circumstances often correspond to Czech sentences which contain the word okolnosti.
Okay.
And this is while sentences that contain the word circumstances, so maybe only once there was the corresponding word záchrana, but in the other sentences it would be not. So this way you can guess that actually these two probably belong to each other.
Okay.
If you want some more details, so Ondřej Bojar has a whole course on machine translation where he explains this and many tricks how to do it, but this is the main idea, that you look for words that appear together frequently, and there is no reason for you to write the code to guess this, because there are tools available already. So you can just use this. And so what you can see if you look carefully is, again, there are some gaps. So for example, for the English word person, which is number 9, there is no corresponding Czech word, which is right because there isn't any. But also on the Czech side, we're missing a link for the word on the position 9, snašeli, which again is true, like there is no English corresponding word. So in the alignment, there will be gaps. So you have to deal with gaps again. And then there will be errors, of course. So it, for example, says that the word to in English, which is hope, it says that it corresponds to the words 2 and 3 in Czech. So na záchran, which is different. This is actually the salvation and not the hope, which is probably because the word for hope was capitalized in Czech and it didn't see it many times. So you might want to lowercase the data before doing the alignment if you want. And there will be also many to one links. So the same thing here. So the same word, hope, is aligned to 2 different words on the Czech side. So you have to deal with cases like that. And if you do the reverse direction of the alignment, so you will get the reverse thing as well, that one Czech word could be aligned to multiple words on the English side. So I'm just showing the one direction of the alignment, and it's fine to use just the one direction actually. And obviously the idea is, so go over the alignment and copy the part of speech label from the English sentence to the Czech sentence. So for example, for the word number 18, circumstances, we have a noun label. So we just copy the noun label to the word 13 in Czech, to okolnosti. So that's pretty straightforward. And this is kind of the base solution. So if you want more points for the assignments, so then you should implement some other tricks, and Dan showed some of the things that you can do to improve the results. And obviously you can just look yourself and try to improve it yourself based on your guesses. And so there is actually a script prepared for that part of speech project, which does just that. It takes, so I will show how you run it. So I've copied it here, and you give it the source data, so the English convolute file, and the target data, so the Czech file also prepared in the convolute format, so in this tab format. And you give it the alignment. So this is what came out from the alignment. And if you run this, and I will save it into a file. So, okay, so it puts in a lot of underscores. So 1, 2, and 4 from the output. Yes, this is what I want. So I will show again the alignment, and I will show these outputs. So this is the output of the script when you run it just as it is. Well, maybe you have to fiddle with a number of sentences it has to process, but it does do the copying. So for circumstances, you get the noun label. For the word naděje, which means hope, actually, it was aligned with the word number 1, a determiner. So you get a determiner, which is not optimal. And sometimes the alignment is fine. For example, word 13, even, it corresponds to I in Czech. So the meaning is corresponding, but actually in English it's an adverb, and in Czech it should be a conjunction. Well, it doesn't know, so it just puts a conjunction. So you get some guesses, which sometimes are correct. So the verb is correct, and I don't know, this noun is correct, the punctuation is correct, and a lot of it is incorrect. But without having any part-of-speech annotated data for Czech, we managed to get like, I don't know, 30% of the words tagged correctly, which is not bad. And I just used the simplest pass. Of course, you're free to, or you should actually modify the projection script or write your own. And it processes the conal files for you. It reads the alignment files for you and processes it. It reads the sentences. It skips like these comment lines. It also does the shifting of the IDs somewhere. I don't know where, actually. Can't see it now, but somewhere I think it does the adding +1 to the, oh no, it does the opposite. So for the UD file, it subtracts 1 from the ID so that the numbers match the alignment numbers. And then here, it just does the projection in the simplest way. So for each token in the target sentence, it looks for its aligned source token and just copies the label. So this is a start. And actually, we still would like to evaluate how good the results are. I don't have the data for this here, but this is, you can do two things. Either you train a tagger on these data, a UDPipe tagger. There is the command to do that, and then you can use UDPipe to evaluate it. Or the other option is that actually we do already have a tagger for Czech. So you can just use the UDPipe model for Czech and tag the data with the UDPipe model and then measure how often the labels match or not match. This only works if you select a target language for which there is a tagger in UDPipe. But this is just the evaluation part. So if you choose a really hard language, so for example you choose a language for which there actually is no annotated data available, so but if you speak the language or if you understand the language a bit, or at least using some Google Translate or something, so you can at least manually estimate how often the labels are correct. So that's also a good evaluation. If it's a real under-resourced language, you have no other option. So you just look at the outputs and you just count. Okay, you look at, I don't know, 20 words, and you say, okay, so from these 20 words, I think that in 15 cases it's the right label, in 5 cases it's the wrong label. So I can guess that I have a 75% accuracy, just like that. So so that's all. That's the task, and I've shown just the simplest path. So if you just mimic the same thing I did here and don't do anything extra, so you will get still like 2 points for the homework assignment, just to try to make all these tools working. And obviously what we are interested in most is try to make it better. So obviously this has a lot of problems, so try to at least do some improvements, and you've seen some in the lecture. You can think about others. So we already see a simple fix for this one. If you lowercase it, then the alignment is probably better. There are these gaps. So for this gap, we didn't predict anything. And obviously you should predict at least something. And usually noun is the most frequent word. So you can just predict anything you don't know is a noun. Then probably we cannot predict the label here, but maybe we could see this same word in another sentence where it would be aligned to something. So we could just copy it from there. And maybe you could just collect type-based statistics. So not doing it per sentence, but just, well, doing it per sentence, but just making a statistics, how often this one was labeled as a noun, how often as something else, and then just assign the most frequent label to anything. You can use some bigrams, trigrams to say, okay, if there is a determiner, then probably there should be a noun after that. Well, in this case, it is. So there's a lot of options that you can try, and you're free to try to go as shallow or as deep as you like. That's as always up to you. And As always, please submit, well, the code that you used, but maybe you do it interactively, so maybe there isn't a lot of code, just maybe the projection script. But what we're most interested in, again, is the report. So report which language you chose, which source languages you chose for it. Well, I didn't say you can also do some voting, so you can use 3 source languages, do the same 3 times, and then have a voting on which it was aligned to in which of the languages. And so try to report what you did, and especially what results you got, more or less. So then it can be either a precise measurement if you have some annotated data, or it can be just some guess, but just try to say what you got. And if you do some improvements, so try to guess the accuracy before and after the improvements to see if it helped actually. And if you're then even more interested in the task, then there are some more notes, like if you even don't have sentence aligned data, then there is a tool that you can use. In Opus, there are other parallel data than the Jehovah Witnesses. So maybe Open Subtitles is what people often use. These are subtitles for movies. And you could also try to do some word-based translation. The data is probably too small to train a full machine translation system, but you could try, but you could at least try to, well, estimate some translation system that just translates one word to another word. So these are just some options. It's not obligatory to do that. It's just if you wanted to. And obviously the deadline will be next week, Sunday, as usual. So I have to update the website in this sense. So I will again show this thing. So just to recap, so the input is an English sentence which we can tag, and the output is, well, we have in this case a Czech sentence which we cannot tag. So we do word alignment on parallel corpus, and we copy the tags from the source sentence to the target sentence, and we get something like that. So that's the basic idea of what to do. Questions, suggestions, problems? Okay, seems there are none. So I guess that's all from me. I don't know if anybody has anything else to say. Probably not. Great. Okay, so thanks for attending. Sorry for the confusion and for making the class a bit longer. I have been recording the class, so I will put it online, well, today. So that's there, and I will update the website with what we talked about for the SIGTIP share task. So just a few notes what to try out, and you are free to decide whether you want to focus on the assignments like the post tagging, and then there will be some parsing assignments which will be similar, or whether you want to do the SIGTIP, or you can try both. That's up to you completely. So enjoy the weekend, and hope to see you next week. I hope there is no holiday yet.
Thank you. Thank you. Bye.
Thank you.
Thank you. Bye-bye.
Bye, everyone.